begin by pointing to a file that has our event-related data for our order-to-cash process. Now there are three fields which are going to be required in order to get started. The first thing we map is a timestamp or a date time field. This is simply going to tell us when an event has occurred. Next, we'll map our timeline ID or unique identifier field. In this case will be an order ID. This is going to allow us to join together all of the events in a given order instance into the same context. Lastly, we'll want to have an event name, or in this case we'll map this to a workflow step, which is going to tell us what piece of work happened at that step. Now these are the only three fields which are going to be required, and lastly we can also bring in additional fields which you may consider to be dimensions or ways that you'd want to slice and dice that data. So we'll add some attributes here, things like the employee, the location, the day of the week the order was processed, and the shift that it was processed on. So now we've mapped some columns in a file, and what I can do is simply hit load and allow the tool to begin reconstituting the process and building the forms of analysis. But it's worth mentioning here that the timelines can be assembled from multiple files corresponding to different systems of record. So while we're only mapping to a single file here, different events could be coming from different sources. As long as they have this same unique object identifier, we'll be able to connect them together within the tool. So we'll confirm and start the upload. And it should take about 10 seconds for this data to load. It's going to reconstitute the process, build out all of our models, and create the multiple forms of analysis that we're going to be going through. Once our data has successfully been loaded, we're then presented with the overview page, which includes quite a few metrics which are going to give us a better understanding about our order-to-cash process and the data that we've uploaded. The first thing I'll point your attention to is that over 11,000 events have been loaded and mapped into 1,312 timelines, or in this case a timeline is going to be synonymous with an order. And we've pulled out 11 different types of events from that data, and if I pop those up you can see all the events listed here. You can sort them by the most commonly occurring events or those which are associated with the most amount of timelines or orders. The only other thing to mention here is that we've got a couple of icons which have been assigned to use as opposed to the default circle with a number in it. So I can show you can upload your own icons, use the ones we provide, or simply use coloring to make events stand out. So this allows users to quickly identify specific events or critical touch points in the workflow, and you'll see this will become more important as we move on to the timeline analysis. So that's all that we've done. Everything else is automatically set up by the technology. So some of the metrics that have automatically been calculated from the data are our average and total range of duration in our process. So you can see on average we process orders within 8 days, but it can range anywhere from 2 days to 21 days. The number of events in a given order instance, along with the unique count of events, because of course events can be duplicated or done multiple times in a single order. We've got the time gap, and this would be the delta of time in between any two events where essentially no work was occurring on orders. This will also become more obvious when we get into the timelines view. And then lastly, we've got the distribution of the first and last events in this order to cash process. Essentially, which events are most commonly both starting and finishing our process. And by clicking on either one of these, I can pop it up and get a full frequency distribution as to, in this case, which are the events which are most commonly finishing my order to cash process. From here, let's move to the timelines view to take a look at the actual process paths which the tool has generated. So I've got all my timelines here in the center of my window, and each of these different horizontal lines with the circles on them represents a separate order, and each circle represents an event or a step which has occurred as a part of that order process. So you see I can mouse over and get the details. Now the length of each timeline is actually proportionate to the elapsed time, so of course some are going to be longer than others, and this includes those time gaps in between any two events where nothing has happened with the specific orders. So we may start to see some glaring examples where bottlenecks may be occurring or our process efficiency can be improved by just looking at this screen. Now, by clicking on any one of these timelines, it's going to give me much more detail as to what has happened with this specific order, in what order, and at what time. So this screen is showing me details specific to timeline or order number X. Now the column all the way to the left is the superset of all of the events which have occurred as a part of this order. We can see when it was received, if it was put on hold, the stock was checked, and so on. Now you can see some columns to the right which the tool has automatically broken out. So using statistical analysis, it's picked out certain events which are most commonly done together as sub or parallel processes and grouped them out here together. So most often when our stock is packed, it's then followed by a goods ship step. So we can see we've done a bit of automatic statistical analysis to pull out things that are done as mutually exclusive or parallel steps. Now, if we think about loading up data across multiple systems that underlie this order to cash process, we're essentially piecing together the composite life cycle of this order throughout the entire process, regardless of the system of record which is responsible for recording these events. And this is a good place to mention that the engine itself doesn't know the first thing about order processing or the order to cash process. We could just as easily be doing this with any other type of process related data, sales, invoices, insurance. It's totally agnostic to the industry and the use case. The idea is to give users a much better understanding of what's happening in their business process, regardless of the type of vertical which is being supported. So let's close out this order and head back to the timeline view. There's a huge amount of variability in this process, and after having worked with this data, I can tell you that there are no two timelines which are chronologically exactly the same. So one might ask if there's some sort of way to map a process diagram that's going to generally explain how orders are flowing through our process. This is a question that most businesses will struggle to answer using their existing technology set, and is a big reason why many people can't tell you with a high amount of confidence exactly how their processes are being executed. So the process schema editor gives you the ability to map that most common path through the process, and will first do that by allowing the software to take what it believes to be the most important milestones. So by selecting the Select Default Milestones button, what's happening here is the tool is using advanced statistical analysis and specifically choosing which steps are most reliably and commonly occurring at the same point in the process. So it picks 6 milestone events for me that are most typically happening at the same point in the workflow. And this looks good, but I have some others I'd also like to add to the model. So let's include when the customer check happens, if an order is rejected, and also when stock check occurs. So I've added a few more, and we'll have it generate that schema. So this is showing that most common schema based on the milestones that we've said we care about. The nice thing is this is not just a Visio diagram. If I save this, it can now become a monitoring tool. It tells me what number of orders have followed which paths. And you can see by the thickness of the line where more orders have followed versus the other paths. I can look at it also by the time length. So where are we spending the bulk of our time in this order to cash process? And if you mouse over, you get the average duration of a certain transition. Again, being able to put this in a way for users to begin to understand most commonly how the process is being executed. Now we can even take this a step further and start to better understand where steps that generally don't always occur in a specific part of the process are most often happening. Let's think about an order put on hold step. Right? This could happen at any given point of this process, anywhere from when the order is received all the way until it's either completed or rejected. This makes it unreliable to add to this schema model. Now we can start to understand where that's happening by selecting the location of our order hold event, and now you'll see the icons and the percentages in between the steps on the lines where we're most commonly placing our orders on hold and thus elongating the process. So now that we have a much better idea of how orders are generally going through our process, let's go back to the timelines view and we'll take a look at a couple of other analysis applications. Let's put this in a way which is easier to begin analyzing. And we'll do that with the path analysis. This is showing us a frequency distribution of all of my process paths with the most commonly followed behaviors here to the left. So we can see along the top the number of orders and their percentage of the whole, and along the left the milestone events. So this is clearly going to expose when steps have been skipped over, done repeatedly, or totally out of order, with the most commonly followed paths highlighted for us. Now the tool has suggested these steps along the left, but we can make changes to this at any time. If I'm not concerned with customer onboarding being a part of my analysis, I can simply uncheck it and you'll see all of my statistics will dynamically recalculate based on the new model that I've created. Now, these behaviors toward the left probably shouldn't come as much of a surprise. These are the most commonly followed process paths. But if I scroll to the right, you'll see more and more unusual or obscure behaviors where things are jumping around and skipping steps. One that stands out to me is this example of 77 orders which have been received, skipped a number of steps, and gone on to have the stock packed. That's a bit of an interesting flow for our order to cash process. Now what I can do if I find a specific behavior that's of interest, I can simply select this row or this column, apply this as a filter, and now when I come back to my timelines view, you'll see I'm now looking just at those 77 orders which exhibited that specific behavior. So filtering down these specific cases will allow me to drill in and hopefully uncover a root cause for this behavior. And that filtering, you'll see, will become a theme as we go. So we'll start with our large data set and begin to whittle it down to more manageable sizes. Now in certain cases we'll build in specific conditions, or sometimes let the tool do the analysis on its own to try to uncover the interesting things that are happening as a part of the process. With my full data set, it's helpful to use the metrics along the top to start to get a better understanding of our data, as opposed to scrolling through all 1,300 plus cases. Now these metrics are always going to be representative of the set of timelines which we see in the window below. And you'll see these recalculate and change dynamically as we filter and scope our analysis. So right now we're looking across all 1,312 orders. And in looking at the duration metric, the fact that there was at least one order that took 21 days to process stands out. Let's drill a bit further into this. So by clicking on my duration metric, I'm now presented with a histogram which shows me the distribution of my orders by their duration. So we can see the minimum time is 2 days, the average is 8 days, and the maximum is 21 days. You can see this is pretty evenly distributed, and what I can do is actually adjust this slider and set it at a certain threshold to see how many orders fall above or below this 10-day threshold that I've set. So now I've set it at 10 days and it looks like 72.7% or 954 of our orders are processed in under 10 days, but there are still 358 or 27.3% of our orders which are between 10 days and 21 days. Now we'll come back to this, but I can take this a step further. If I want to investigate by any of the dimensions or attributes that I've loaded into the system, I can do that here as well. So let's break it down by the different locations that we have. Now each one of my different locations has their own respective duration histogram relative to the orders that that location has processed, and I could then sub in any location's histogram to see how it compares against one or the other. So our general average is 8 days, but Los Angeles's average looks like it's about 2 days longer, 10 plus days in order to process an order. Let's go back to our general histogram. I'll set my threshold at 10 days, and if we're truly want to analyze this process, we'll want to look at these 358 which span longer than 10 days. So I'll apply this as a filter. Now we're looking just at those 358 orders. The next thing I'd logically want to do is try to see if there's any kind of trends in the data that are going to give me an idea as to root cause. So I'll further break this down by another attribute to see if these delays are related to a specific location, an employee who is responsible for handling these longer orders. We'll use the breakdown application for that. And so what you can do is select any of the events, and again, any of the different attributes that we've loaded into the tool, and see a frequency distribution of how commonly they're responsible for that. So let's use the employee example right now. And it looks like somebody does stand out. Thomas Moore has been accountable for 57% or 204 of those long running orders. Now, I know if I want to take some remediation efforts, I probably need to go have a conversation with Thomas to understand exactly what's going on with the orders that he's been responsible for processing. Search or query is hugely important. Now, while traditional BI search will look for objects by using their current attributes or status, what if we need to look for things from more of a historical perspective? For instance, if someone wants to know how often we have orders with no record of ever been shipped, also being flagged as being completed. Now, it seems like something like that probably shouldn't happen, but by only using a typical BI search, you'd have a very difficult, if not impossible, time answering that question. So let's build this out visually in the query editor. I'll add a step that says the goods were shipped, followed by the goods being completed, the order being completed, but in this scenario, we're missing the goods shipped step. So this has not happened, yet the orders come back as being completed. If I click search, I'm very quickly presented with the 77 orders which have had this specific scenario occur. We missed the shipping, but they're flagged as being complete. It's a bit interesting. I'll give you one more example. Let's get rid of this query and modify it a bit. So we'll say we have record of the order being put on hold, and then it comes back as being rejected by the customer. So we'll say also we can specify the number of times that this order has been put on hold. So let's say it's been put on hold more than 2 times and the customer has come back and rejected that order, possibly because it took too long to get the goods out to them. If I look based on this criteria, I actually find the 3 orders where we put the order on hold more than 2 times and also the good came back as rejected from the end customer. Now, the ability to go off and explore and test these type of hypotheses is great, but another aspect of these queries is that you can set them up to trigger alerts. So we don't need to sit and babysit this data all day long. We can simply configure alerts to fire off when conditions are met, making people aware that these types of cases are occurring and building another level of accountability into our process. As we get into more specialized forms of asking questions, we can look at our protocol analysis. A good example of a protocol is in financial services. When somebody applies for a mortgage or a consumer loan, they have to get certain disclosures, good faith estimates, signatures. These things that the government requires are taken into account. Now, these things are mandated and absolutely must be done the prescribed way, otherwise you'll be in violation of federal law and your loan will be null and void. Now, likewise, most processes include areas where when we get to a certain point, there are things that absolutely must happen and within a given time range. Now, in comparison to a query which says, give me all the cases which match my condition I've created, protocols will allow me to define a set of rules which should always be followed and will show me the timelines that violate those rules. So in other words, it's going to be the inverse of that query in that it shows the timelines which don't match the rules that I've set forth. I've got a simple restock protocol created here that says once our goods are shipped and our order comes back as being rejected by the customer, I want to make sure that I've restocked those goods within 10 days of that order rejection notice. Otherwise, our goods are essentially sitting and waiting in limbo. Now, what's nice is these protocols can be set up to fire off alerts, just like queries. So I can be notified anytime we were to breach an unacceptable threshold. Now, just opposed to looking at new data coming into the system, we can also use these protocols to analyze our historical data. So if I click Show Violations, Here are all the different ways that this protocol has been violated using my historical data along with its root cause. So restock was missing, or we had a time violation on the restock. Now if either one of these violations stands out, I can apply them as a filter and drill into specifically those orders which have exhibited a protocol violation.